Artificial intelligence is entering a new phase. Instead of systems that simply respond, we are now building systems that can plan, decide, act, evaluate, and improve on their own. These systems are known as Agentic AI. In this masterclass, we will go step by step through everything you need to understand Agentic AI clearly. We will explore when to use agents, when not to use them, how agentic systems are built, how workflows guide behavior, how agents collaborate, and how tools are designed for agents. This is a complete learning journey designed to give you a deep and practical understanding of Agentic AI. Agentic AI refers to artificial intelligence systems that operate as goal-driven agents rather than passive responders. These systems do not stop after producing a single answer. Instead, they continuously work toward a goal by planning steps, taking actions, observing outcomes, and adjusting their strategy. An agentic system behaves more like a human problem solver. It can handle uncertainty, change its approach when something fails, and keep going until the objective is achieved or stopped. This ability to reason over time is a defining characteristic of agentic AI. Traditional artificial intelligence systems are reactive. They receive an input and generate an output, then stop. Even advanced language models usually follow this pattern. Agentic AI systems are different because they are persistent. They maintain internal state, remember past actions, and continue reasoning across multiple steps. For example, a traditional system can answer a question about a project plan. An agentic system can create the plan, check for missing details, revise it, validate assumptions, and refine it further. This persistence is what makes agents suitable for complex, real-world tasks. Agentic AI should be used when problems require multiple decisions, involving context, or long-term reasoning. These include research tasks, planning systems, monitoring systems, complex automation, and decision support. If a task requires the system to decide what information is missing, choose among multiple actions, or revise its output based on feedback, agents are a strong fit. Agentic AI excels when the path to the solution is not fixed in advance. Not every problem needs an agent. If a task is simple, predictable, or requires strict control, agentic systems may be unnecessary or even harmful. Examples include formatting text, basic classification, translation, or deterministic business rules. Using agents in these scenarios increases complexity, cost, and risk without providing additional value. A key skill in designing agentic AI is knowing when simplicity is better than autonomy. Designing agentic AI requires a shift in mindset. Instead of focusing on single prompts, designers think in terms of systems. The focus moves from asking the right question to defining the right goal, constraints, feedback loops, and workflows. Agentic design emphasizes control, observability, and iteration. The goal is not to make the agent clever, but to make it reliable, understandable, and aligned with human intent. Agentic AI systems are built from several essential building blocks. These include goals, reasoning mechanisms, memory tools, feedback loops, and control logic. Each block plays a distinct role. Goals define what success looks like. Reasoning determines what to do next. Memory preserves context and experience. Tools allow interaction with external systems. Feedback evaluates outcomes. Control logic enforces limits and safety. Together, these blocks form the foundation of intelligent agent behavior. Building blocks can be grouped into functional categories. Decision blocks choose actions. Memory blocks store information. Execution blocks perform tasks. Evaluation blocks judge outcomes. Control blocks enforce boundaries. Understanding these categories helps designers reason about agent behavior and diagnose failures. A well-designed agent balances all block types instead of over-relying on a single capability. Agentic workflows define how an agent organizes its reasoning and actions over time. A workflow is not a rigid script. Instead, it is a flexible structure that guides behavior while allowing adaptation. Workflows determine how steps are sequenced, repeated, branched, or parallelized. Choosing the right workflow pattern is one of the most important design decisions in agentic AI. Prompt chaining is a workflow where a task is divided into sequential steps, and each step builds on the previous one. This improves clarity and reduces errors for complex reasoning tasks. For example, an agent writing a report may first create an outline, then draft sections, then review coherence, and finally polish language. Each step focuses on a specific objective, making the overall task more manageable. Routing workflows allow agents to select different paths based on context, input type, or intermediate results. Instead of following a single path, the agent decides where to route the task. For example, an agent handling user requests may route technical questions to one process and business questions to another. Routing improves relevance and efficiency. Parallelization workflows allow agents to perform multiple independent tasks at the same time. This is useful when tasks do not depend on each other. For example, an agent performing research may collect information from multiple sources simultaneously before combining results. Parallelization improves speed and scalability. In this workflow, one orchestrator agent manages the overall goal while multiple worker agents handle specialized subtasks. The orchestrator assigns work, collects results, and decides next steps. This structure is useful for large or complex tasks that benefit from specialization. It mirrors how teams operate in human organizations. Evaluator optimizes workflows separate generation from evaluation. One component produces output, while another evaluates quality and suggests improvement. This loop repeats until the output meets defined standards. This workflow is particularly effective for tasks that require high accuracy or quality, such as analysis, planning, or content creation. Agents can be categorized by their role. Planner agents define strategy. Task agents execute actions. Evaluator agents assess quality. Coordinator agents manage other agents. Memory agents handle long-term context. Real-world systems often combine multiple agent types to achieve robustness and efficiency. Frameworks provide reusable structures for building agentic systems. They simplify memory management, workflow coordination, and agent communication. Frameworks are helpful when systems grow complex or involve many agents. However, for small or experimental systems, frameworks may add unnecessary abstraction. Designers should adopt frameworks gradually and intentionally. Agents rely on clear instructions when interacting with tools. Prompt engineering for tools involves defining what the tool does, when it should be used, what input it expects, and how to interpret output. Clear tool instructions reduce ambiguity and prevent misuse. Well-designed tool prompts make agents more reliable and predictable. Agentic AI represents a shift from reactive systems to autonomous, goal-driven intelligence. Mastering agentic AI means understanding when to use agents, how to design building blocks, how to choose workflows, and how to manage collaboration among agents. Start simple, add structure gradually, and always prioritize clarity and control. If this masterclass helped you understand agentic AI deeply, support the channel by liking, sharing, and subscribing for more long-form artificial intelligence education.